Welcome to the Jumble tool, the online application for structural analysis of data. In this video, we will show you how XML files can be inspected and processed. Let's start with a simple example. The file contains the XML prologue on the first line, one root element called library, and two sub-elements called book. Each book element has one attribute named ID and three sub-elements title, author, and year. Once the file is uploaded, the XML data appear as a graph. The root node of the graph is the upload node. It contains the file node, which has three subnodes. The red one in the middle represents the root XML element. It is labeled element and it has three properties. The level for the root node is 0. The name and the path is the tag name library. The green nodes represent white spaces before and after the root element. Similarly, the library node contains 5 subnodes. These represent the 2 sub-elements and 3 white spaces. The sub-elements have level 1. The element name is set to book and their path is library book, which is the concatenation of all element names from the root to the element. Please note that all elements and texts have property n, which reflects the order of the subnodes. On the right, we can see that each book element has one attribute node shown in blue. Both attribute nodes have properties name and value. Besides attributes, the book elements have other texts and sub-elements with the book details. In general, the nesting of the XML is reflected by the structure of the graph. The graph nodes represent elements, attributes, and texts in the file. The properties of the graph nodes store data extracted from the file. Please note that some data might be slightly redundant. For example, some scenarios might need the element name, different ones element path, and other scenarios use the element level. While the data is on the right, the panel on the left contains the digest. We have made up this word to avoid heavily overused terms such as a model or a scheme. The digest shows a simplified view of the data, its structure, and statistics. All nodes with the same label are shown in the digest as one concept. For example, the 9 elements on the left are represented by this concept on the right. Similarly, all edges with the same label running from nodes with label A to nodes with label B are represented as one relationship. For example, the 2 edges from XML elements to the XML attributes are represented by this relationship. Some relationships might not seem intuitive at first glance. This relationship represents the edges between the nodes labeled element. It is a self-loop, but the graph does not contain any self-loops. This follows from the fact that multiple nodes are aggregated into one concept. In general, even when the data graph is acyclic, the digest might contain cycles. The digest shows representation of properties for both nodes and edges. It presents the name and the statistics for each property, how many times the property is used, and what the types of values are. So far, we have used a tiny XML example. Let's see how the tool deals with something larger and more complex. This is a medium-sized XML. The XML elements and attributes have different names and organization. Once the file is uploaded, we can see the file has more elements and attributes. The graph is larger and more complex. The digest, however, looks almost identical to the smaller file. The structure is the same. We can see just different values of numbers and some properties. This results from the fact that the initial structure of the data reflects the packaging mechanism. In our case, the XML is always just a hierarchy of elements with attached texts and attributes. We need to process the graph to see how the elements are nested and what attributes attach where. Please check the links below. Thank you for watching, and please let us know if you have any questions or comments.